Good morning, student. Namaskaram. Today we are going to discuss uh, 11th physics. Okay. So in 11th physics, chapter name thermodynamics. Today we are going to discuss the topic second law of thermodynamics, and then we will discuss later that is difference between the heat engine and the refrigerator. Okay. First of all, what is the definition for second law of thermodynamics? Okay, what is the definition of thermodynamics? Second law of thermodynamics. So, second law of thermodynamics said that for all the processes that occur in nature, because all the process in nature is irreversible process. Yeah, irreversible process. Okay. So, so all the process means irreversible processes. Okay. In nature, the entropy always increases. So increases. I denoted as this arrow increases. For reversible processes, entropy does not change. That means constant. This is the second law of thermodynamics. Okay. For all the process that occur in nature, that is irreversible process, the entropy always increases. Because what do you mean by entropy, sir? Entropy means it is a measure of disorder. Measure of disorder. Entropy means measure of disorder or measure of unavailability of the energy due to work. For example, in solid, atoms are like that. So well structured. In liquid, molecules like that. In gas, for example, okay. So this is liquid, this is solid, and this is gas. So here, disorder is very, very, very less. Yes. Here, between that solid and gas. Here, disorder high. So disorder high means, so we know that what is entropy? Entropy is nothing but it is a measure of disorder. Disorder mean how the atoms or molecules arrange in that system. Okay. So we know that in solid atoms like that, and in liquid atoms like that. Okay. In gas atoms. So you can see, sir, this is more structure, sir. This is less structure, sir. This is very less structure, sir. Because disorder is high. Disorder is between that two solid and gas. This is disorder is very, very, very less because order. Okay, va? So gases have more entropy. It has more entropy. Liquids has less entropy, and solid has least mean very, very less. Okay, least entropy. Now you may clear with that what is that entropy and how the entropy defined in the second law of thermodynamics. Okay, is it clear? Okay. So this is a second law of thermodynamics and entropy. Entropy in terms of in our universe, there is three uh, type of phases. Yeah, yeah, solid, liquid, gases. So orderness and how the entropy is separated, classified. according to that order. Okay. So solid has least entropy, liquid has less entropy, gas has more entropy because orderness very less. So gases have the option to arrange in some order because there is more chances. Yeah. So here. So more entropy. Okay. So now we are going to discuss differences between that heat engine and refrigerator. Okay. Differences between heat engine and refrigerator. Differences between heat engine and refrigerator. First of all, we have to discuss heat engine. Okay. Then we will go into that refrigerator. So heat engine diagram. This is hot reservoir. This is hot reservoir. And this is heat engine. Okay. Heat engine. So arrow mark denotes that work done by the system. So W, work done by the heat engine. And this is cold reservoir. This is cold reservoir. Okay. So arrow mark denotes that like that. This is Q1, this is Q2 or QL, or this is QH because temperature for this hot reservoir TH, temperature for that cold reservoir TL. Okay, right. So there is a heat transfer between that hot reservoir or hot region to cold region. Yeah, already you know that heat always transfer from that hot place to cold place. So it is an example of second law of thermodynamics because that law state that already we know that heat naturally flows from the hotter to cold region of matter. So, second law of thermodynamics is a for example for heat flowing into the cloud is an example of second law of thermodynamics. Heat always flow from the hotter object to colder region. Okay, colder place, and never in the reverse direction. Yeah, never in the reverse direction. Heat always flow from cold region to hot region is wrong. Okay. So because the natural process always heat flow from the hotter to colder object, cooler substance, cooler place. So result in the greater disorder. Yeah, from hotter to colder, result in the greater disorder. Greater disorder means high entropy. So entropy increases. Yeah. So this is the sign law of thermodynamics. When hot object contact with the so this is a hot object. Okay, this is a cold object. When hot object is brought into contact with the cold object, the hot object cools down and the cold object heats up until an equilibrium is reached. Equilibrium means same temperature between these two objects. So whenever there is a difference between the temperature between these two bodies, heat flows from one object to hotter body to colder body. Suppose the two objects is in equilibrium, that means the same temperature, heat does not flow. Okay. So that only hot reservoir, cold reservoir, heat flowing into that hot to hold is an example of second law thermodynamics. Clear? Okay. So we can define the heat engine. Heat engine is a device. Okay. Heat engine is a device which takes heat as a input. So heat as a input and convert this heat into work. Okay, convert this heat into work by undergoing one that is a cyclic process. Okay, so this is a basic principle of a heat engine. Heat engine is a device which takes heat from that hot receiver and converts that heat into work by undergoing cyclic process. So heat engine has three parts. So you can see that. What are the three parts? Hot reservoir, cold reservoir, and working substance. Here is working substance. Okay. Working substance, it may be gas or liquid or water. Okay. Gas or liquid. Okay. Clear? Okay. So heat engine has three parts. So hot reservoir, cold reservoir, working substance. Working substance absorb the heat from the hot reservoir and convert to work and reject some heat to the cold reservoir. We can discuss in detail later. Okay. So heat engine. So hot reservoir. So which is a source because it gives heat. Yeah. So it heat, supplies heat to the engine. Yes, to the engine. It always maintain at a high temperature. Okay. It always at a high temperature. High temperature that called as high. So high. TH. Second one, working substances. Already I told you working substances may be gas or water. It is a substance like gas or water which converts this heat into work. Okay, converts the heat supplied into work. For example, heat engine. For example, one example for heat engine is a steam engine. In olden days, steam engine were used to drive trains. Already, know that. In the train, working substance is that water. So water absorb heat from the burning coal, and that heat converts the water into steam, and the steam does work by rotating the wheels of the train, thus making the train move. So this is a step by step for that steam engine. So steam engine example for or good example for heat engine. Okay, right. So then third one, cold reservoir. Third one, cold reservoir. Cold reservoir are also known as sink. Okay, also known as sink. The heat engine ejects some amount of heat to the cold reservoir. So engine eject some amount of heat. So eject heat to this cold reservoir. Okay. So after doing some work and cold reservoir always maintain at a low temperature. So low temperature means TL. Cold reservoir always maintains a low temperature. Okay. Clear? Right. So this is a important points for that heat engine. Okay, this is an important point for heat engine. So now you may clear with that how the heat engine can be defined. Heat engine converts heat into work. The working substance absorb heat from the hot reservoir and convert into work. Working substance may be gas or water, and working substance reject heat into that is heat that heat denoted as Q2. Q2 into cold reservoir, and that cold reservoir always maintain at a low temperature, TL or T2, whatever may be. Okay, whatever may be, it can be denoted as. Okay, in this heat engine, already draw a arrow mark to the outwards, like heat engine and arrow mark here and work. That means how much of work is done by the system. So work is done by the system. So working by the system. Suppose arrow mark towards this work is done on the system. We will discuss in the refrigerator later. Okay. So in that case, work is done on the system. So this is work is done by the system. Okay. And then efficiency of the heat engine. Efficiency of the heat engine. Efficiency denoted as eta. Eta. Okay. So efficiency means how that device works well. Okay. It is a measure of how the device works. So eta equal to output by inputs. Output by inputs. Here, output means what done, because what done by the system. Input means you give some heat into the engine. So input Q1 or QH. So W by Q1. W means which is a what done. So QH minus QL or Q1 minus Q2 by here Q1. So we don't need to QH or QL. So Q1 minus Q2. Because heat is supplied, work is done, and some amount of heat ejected. So Q1 and Q2, which gives work. Yeah. So Q1 minus Q2 by Q1. This is a efficiency. So this Q1 belongs to both quantity. So Q1 by Q1 minus Q2 by Q1. So Q1 by Q1, 1. So we can cancel it. Yeah. So 1 minus eta, 1 minus Q2 by Q1 is another form of efficiency. You can write all the equations. Okay. Output by input, W by Q1, Q1 minus Q2 by Q1, 1 minus Q2 by Q1. These are all the efficiency of the heat engine. And in that heat engine, efficiency always less than 1. Eta always less than 1. Why, sir? Efficiency always less than 1 in heat engine because Q1. So here Q1 minus Q2. Q1 means high temperature. Q2 means low temperature. So suppose you divide the low value by the high value, it will become too low. Yes. You can divide 5 by 25 or by 5 by like or 2 by 2000, 2 by 1000. it will become into too small value after that. So Q1, Q2 by Q1, which gives even small value. Yeah. So 1 minus small value gives less than 1 value. Yeah. So that's why I'm saying that efficiency always less than 1. So these are all for the heat engine. So now we are going to discuss refrigerator. So refrigerator. Okay. So first of all, I will draw that refrigerator working condition like schematic diagram. So this is, you know, that hot reservoir. Yes. This is that engine. So here refrigerator, and finally this is cold reservoir. So here W, okay, W arrow mark like that. Okay. So W towards refrigerator. Arrow denotes that towards the refrigerator, and here arrow marks like that. So this is QH. Okay. This is QL or QH or Q1, Q2, whatever may be. Okay. Also always correct. Okay. So this is QL, Q2 or QH, Q1. Okay. So here working substance gas. Okay. Which observe heat, quantity of heat from the cold body. Gas absorb heat. So heat from that cold reservoir. So cold reservoir at a low temperature, that is QL or Q2. Okay. That is sink. Already you know that this is sink, this is source. But refrigerator is the reverse of heat engine. So refrigerator getting heat from that cold reservoir. So which is at lower temperature. So TL or T2. Okay. Certain amount of work is done on the working system. So work is done on the system. Work is done on the system. Done on the system. Okay. So in refrigerator, certain amount of work is done done on the working substance by compressor. Already you know that that word compressor in the refrigerator. So that compressor having doing some work on that working substance. Okay. And quantity of heat Q1 or QH rejected into hot reservoir. So QH or Q1 ejected into hot reservoir. Okay. Rejected into hot body, that is called as source. So or the atmosphere. So atmosphere means refrigerator placed in the kitchen. So kitchen is a atmosphere. Kitchen is a environment for that refrigerator. So absorb heat from the whole reservoir and work is done on the system and ejected some amount of heat to the hot reservoir, because you can compare with that temperature between the inside of the refrigerator and the outside of the refrigerator. In the outside of the refrigerator, there is a more heat compared to that inside of the refrigerator. So outside is a hot environment. Okay. So heat ejected into hot environment. So when you stand beneath of a refrigerator, you can feel warmth air. Yeah. It is all for for refrigerator. Okay. Right. So refrigerator is a reversible heat engine, working substance which absorb heat Q2. Okay. Q2 amount of heat from that cold reservoir at low temperature, already denoted T2. And working substance reject some heat, Q1 or QH, okay, to the hot reservoir. Hot reservoir at temperature T1 or TH, okay. This is T1 or TH. Hot reservoir maintained at a high temperature. So I denoted as TH. So working substance rejects some heat into the hot reservoir. So here external work is done on the system. This is a system, external work is done on the system. Now you clear that. Okay. So now we are going to discuss that efficiency for the refrigerator. Already you know that efficiency. Yeah. Efficiency eta. Okay. But in refrigerator, we denote it as beta. So beta means it is also efficiency. So beta means coefficient of performance. It is a measure of the efficiency of the refrigerator. So in terms of refrigerator, we introduce a new term, that is beta. Beta means COP. COP means coefficient of performance. It is measure of the efficiency. Measure of efficiency. Okay. So beta, which is equal to QL by W. QL by W or Q2 by W. QL means low temperature from that cold reservoir. Yeah. Q2 means also. So some student familiar with that QL, or some student familiar with the Q2. So whatever which is easy for you, take that QL or Q2. Already you know that W means Q1 minus Q2. So beta equal to efficiency equal to Q2 by Q1 minus Q2. Clear? So the coefficient of performance is greater than 1. Beta is greater than 1 for the refrigerator, because Q2 by Q1 minus Q2. That's correct. So COP greater than 1, because it is definitely the ratio of the heat exerted by the cold body to the external work done. Okay, external work done by the compressor. So beta is greater than 1. Clear? So this is a refrigerator. So now we are well clear with that refrigerator and the heat engine, and what is that statement of second law thermodynamics also. Okay. So I will finish that class. Thank you. We will see in the next class. Thank you. Jai Bharat, Jai Hind, Jai Vidya Shakti. Thank you.